Hi students, this lesson is over solving literal equations. So the equations that we've been learning how to solve have contained only one type of variable, either just x or just y or just b or just g. But a literal equation is an equation that involves two or more different kinds of variables. An example of a literal equation is the formula for area of a triangle. A equals BH divided by 2, or area equals base times height divided by 2. Many times literal equations are formulas that you'll see in math and science. This particular formula is solved for A because A is by itself on one side of the equal sign. We say that it's solved for A in terms of B and H. The in terms of describes what's on the other side of the equal sign, which variables. Another example of a literal equation would be the equations we were using on Friday when we were solving our simple systems. For example, y equals 4x minus 5. This particular literal equation is solved for y because y is by itself on one side of the equal sign in terms of x. So on the other side of the equal sign is an expression that contains the other variable. So many times literal equations are already solved for a variable in terms of another variable, but sometimes we need to rearrange the equations to be solved for a different variable. And that's what we're going to learn how to do today, is to solve for other variables in the literal equation. So let's do some examples. In this example, we are going to solve for y in terms of x. So what we want to do is we want to get this y by itself on the left side. Imagine when we were solving just regular equations, getting that variable by itself. It's the same idea. The only thing that's a little bit different is for our other variable terms, we have to move those to the other side, much like we would when we're putting our variable terms on the same side. So let's see how this is going to work. So remember, y is what we're trying to get by itself. First of all of our y's are together, so that's good. Let's draw our line. We're going to move any other variable terms to the other side. So that 9x I need to move to the other side. We're going to move it by subtracting it, since it's a positive 9x on both sides. When I subtract 9x from 9x, I get 0, and then we'll bring down what's left. So on the left, we've got negative 4y equals. Now on the right, I want you to be very careful. This is where students are going to mess up. These two terms right here are not like terms. So rather than putting them together, I'm going to put them next to each other. It doesn't matter which term goes first. I tend to put the x term first, or the other variable term first. So I'm going to start with the negative or minus 9x, and then I'll follow it with the minus 8. If you want to do negative 8 minus 9x, same difference. So now we look at that side that we've got our y on, still on the left. Now we've got to get rid of that negative for the coefficient. Now normally when you get rid of a coefficient, you divide both sides. However, normally both sides each have one term. So we're used to just dividing each term by negative 4. We have a second term on the right side, so we're going to also divide that by negative 4. So whenever you're dividing by a coefficient, you need to divide every single term in the equation. So make sure that you're doing that. Let's go ahead and simplify. So this part might be a little bit new for you since we have more than one term. On the left, negative 4 divided by negative 4 is 1. So now we've got that y by itself on the left. Equals. Now on the right side, this part I want you to think of as a fraction, and I want you to simplify it. Same with this guy. Think of it as a fraction that you need to simplify. So first of all, if I've got a negative in both the numerator and denominator of my fraction, then my fraction is actually positive, because a negative divided by a negative is a positive. So that fraction, negative 9 over negative 4, simplifies to positive 9 over 4. And then I'll just stick the x with it. My other fraction, negative 8 over negative 4, would simplify to a positive 2. So this would be my solution. Okay? I have solved for y in terms of x. Here's another example where we're going to solve for y in terms of x. So we need to get that y by itself on one side of the equal sign. Since it's already on the left side, we're going to leave it and we're going to move everything else to the right. So the first thing we need to move is any other variable terms. That 8x I need to move over, and I'm going to move it over by subtracting both sides by 8x. When I subtract 8x from 8x, I get 0. We'll bring down what's left. We've got a 5y on the left. Bring down your equal sign. Keep in mind, 20 and negative or minus 8x are not like terms, so you cannot put them together. Be very careful. Pay close attention there. I'm going to put my variable term first, my negative 8x, and follow it by my constant. All right, now we've got to get rid of that 5 that's in front of the y, so we're going to divide every single term by that 5. Don't pick and choose. Every term needs to be divided by that coefficient. 5 divided by 5 is 1. So let's bring down what's left. We've got just y on the left. Yes. On the right, remember, we basically have these fractions that we're simplifying. Negative 8 over 5 is already simplified. Negative 8 over 5. Now remember, when you're writing a fraction that's negative, you can put the negative with the numerator, with the denominator, or out in front. It's up to you. And then bring down that x. A lot of students forget that, so don't forget to bring the x. The other fraction is 20 divided by 5, which is 4. So this is our solution. We have solved for y in terms of x. Here's another example. I want you to notice that the last two examples kind of looked like the same form of an equation. This example and the next one are going to look like another form of an equation, and we'll talk about these forms later in the year when it's more appropriate. For now, I want you to, when you're doing the practice, find an example from this video that looks a lot like it to help you. So this would be another type. So just like before, we're going to solve for y in terms of x. Now notice, I just have that minus 5 on the left side to get rid of. But we also want to be simplifying our equation at the same time. So for this equation, I need to get rid of my parentheses. In front of my parentheses, I've got a negative 4, so we're going to distribute that to both the x and the 1 by multiplication. So let's write down what we have after we do that. On the left, we still have y minus 5. We'll get rid of that minus 5 in a second. Negative 4 times x is negative 4x. Negative 4 times positive 1 is negative 4. All right, now we're ready to get rid of that minus 5 because we have distributed. The opposite of minus 5 is plus 5, so we're going to add 5 to both sides. Now on that right side, look at where you should be adding the 5 to. Put it under the term that's like it. So it needs to be near that constant. When I add 5 to a minus 5, I get 0. So what we've got left is y on the left equals negative 4x, and then I can combine the minus 4 and the positive 5 to make a positive 1. So here is my equation solved for y in terms of x. This equation's a lot like the last one, however we have a fraction. I want you to feel comfortable with these, so that's why I'm throwing in some of these examples. We are still going to be solving for y in terms of x. But before we can move that minus 4 to the other side, we need to go ahead and distribute to get rid of those parentheses. So, outside of the parentheses is 7/3. We're going to multiply that by x and by that minus 3. Remember, we're multiplying. Okay, so on the left, we still have y minus 4 equals, on the right, 7/3 times x is just 7/3 x. Now 7/3 times negative 3. I'm going to go off to the side and do this. 7/3 times negative 3. So I want you to remember how to do this. Put your integer over 1 so that you have a numerator and denominator for each, and then you're going to multiply straight across. 7 times negative 3 is negative 21. That's my numerator. My denominator is 3 times 1, which is 3. And negative 21 over 3 simplifies to negative 7. So this is what I want to put for 7/3 times negative 3, minus 7. Okay? So write that little note off to the side if you need to. All right, we almost have y by itself. Now we got to get rid of that minus 4. We're going to do that by adding 4 to both sides. Make sure you're adding it to the other constant on the other side. Very important that you pay attention to your variable terms and your constants and don't combine any terms that aren't like. When I add 4 to a negative 4, I get 0. So let's bring down what's left. I've got y on the left equals 7/3 x, and then minus 7 and plus 4 combine to make a minus 3 or a negative 3. So here is my equation solved for y in terms of x. So those last 4 examples are the ones we're going to use a lot in this class, and you'll see that in later lessons. It is also important to know how to solve literal equations because it'll help you with not just later math, but also science. So, for example, let's pretend like this was a formula. This one is solved for z in terms of x, but the directions say that it wants me to solve for x in terms of z. So basically, we're just rearranging the equation to make it more useful for our needs, whatever that need is. So we're trying to get x by itself. So what we're going to do is we are going to first get rid of any other terms that don't have the x in it on that right side. The other term is that minus 2. We're going to get rid of it by adding it to both sides. So on the right, when I add 2 to a minus 2, it goes away. On the left, I've got z plus 2. Those are not like terms, so I cannot combine them. So I'm just going to put them next to each other. Notice I put a line through my z's so it doesn't look like a 2. On the right side, we've got that negative 3x. Make sure to bring that negative with it. Now I've got to get rid of that negative 3 in front of the x so that my x is alone. Remember, to get rid of a coefficient, you're going to divide both sides by that coefficient, and if you have more than one term on a side, you're going to divide every term by that, just like we did on the last example. Negative 3 divided by negative 3 is 1. 1 times x is x on the right, equals, on the left, I've got z and 2 both being divided by negative 3. Here's a little trick you can do. If the 2 terms that you're dividing, or maybe even have 3 terms, are all being divided by the same number, and none of the fractions can be simplified, you can even write it like this: z plus 2 all divided by negative 3. So this is just another option. So you could leave your answer like this, or you could keep the negative 3's individually under each term like this. So either one is okay. But either way you have it, you have solved for x in terms of z. It doesn't matter if the variable you're solving for is on the right or the left. So that last example and this example, when you don't have x and y, sometimes it can be a little trickier. I'm not expecting you to be perfect at these, but I am expecting you to maybe kind of recognize what it should look like. So in the practice, for these type of literal equations, I actually have multiple choice just to kind of help you out a little bit. So let's look at our last example. We're going to solve for a. Now notice I've got a on both sides of the equal sign, and we're solving in terms of u. So the very first thing that I need to do is we need to get our a's on the same side. And remember, that's always up to you. I know a lot of you like to put the variable you're solving for on the left. So if we want to move that a on the right to the left, and remember this is like a 1a and it's positive, I'm going to subtract 1a from both sides. When I subtract 1a from 1a, I get 0. So on the left, I've got 9a minus 1a, which is 8a, equals, and then just u on the right. Remember, we're solving for a. So now we just have to get rid of that 8, and we'll get rid of that by dividing by 8, just like we normally do near the end. 8 divided by 8 is 1. 1 times a is a, equals, and u divided by 8 cannot be simplified, so we'll leave it as u divided by 8. So we have just solved this equation for a in terms of u. All right, write down your questions, bring them to class. I know this lesson is a little trickier than what we've been doing, but I promise throughout the year you will get better at it. Good job, guys.